Good day everyone. In this particular video lecture we will be discussing about the first supervised machine learning algorithm, that is linear regression. So this particular algorithm is used for supervised learning. So we know that in supervised learning we have a data set that we already know, and this data set contains input output pairs, and we fit a hypothesis function. So that means we have to find a hypothesis function that fits this particular data hypothesis, or we can also say we want to find out a function that fits this particular data. If we are able to find this particular hypothesis, find this particular function, then we can use this particular function to do the predictions on unknown data. Okay, so this hypothesis function, as you can see from the name itself, it is linear regression. Okay, regression means that in this data set the output that we are trying to predict is continuous, and linear, by the linear term we mean to say that the hypothesis function or the hypothesis class that we are assuming, as I have already said in the last video lecture, that for finding out this hypothesis function we have to make some assumptions related to this hypothesis function. That is, this function can be a linear function, quadratic function, exponentiation, or any other polynomial function. But when we are assuming that this hypothesis is a linear function, then it is called a linear regression. Okay, so that means we are assuming that this particular data set, here the relationship between the input and output can be captured by a linear function. And we know that there are n number of linear functions. Okay, so this complete set of linear functions is called a hypothesis class. Okay, and from this hypothesis class we have to find one best function that is called our hypothesis function. Okay, and how we are able to find this hypothesis function? We will find mean square error on the entire data set, and this mean square error is equal to 1 divided by n. This n is number of data points in the data set, sum of predictions, this is our predictions minus actual values, this entire square, where I runs from 1 to n. So I have already discussed this in the last lecture. So we want to minimize this particular thing. This is also called loss. So we want to minimize this loss. So we will have our final hypothesis function that has this particular loss minimum. Okay, so in linear regression, as I said, that we are trying to find a function, but that particular function will be a linear function. Okay, so before discussing that particular function, let me first recap what is our input. So input is our data set. This is our data set, and it contains data points like this. So this is the first data point input and this is its output. This is the second data point and this is its output. Okay, dash, this is our last data point, mth data point, and this is its output. So we will always assume that in our data set there are m data points, or these are also called m examples or m training examples, and every example here we have an input, and every input will have n features. So that means every ith input will have features like this: xi1 first feature, second feature, we have total n features. So let's take an example of predicting the income of a person. Okay, so we want to design a predictor for predicting the income of a person. So what will be the input? We will say, for example, the input are two things here. One is age and second is qualification, and output will be income. So we will have a data set that will contain the points of various persons where we are given the age, qualification and income. Age, qualification and income. So we can say this is our x, these two together is our input, and this is our output. And you can also see that for any example the input can be written as xi1, xi2. So there are two inputs, xi1 and xi2. So this specifies the age and this specifies the qualification. And our output for any example is only one entity, and that is our income. Now if we are saying that the function, so basically we try to find a function that captures the relationship between the input and the output. Let's say we are saying that our function is a linear function. So that means our hypothesis function is a function of input. So what is input? X. It is a linear function. So how are we going to write a linear function? So linear function is written in this particular format. So the first, you already know the linear function is like this: y is equal to ax plus b. So this is linear function. Output is, these are the parameters of the function, and this is the input. So here we are considering only one input. So let's suppose here we have how many input features? Two input features. So we can say y is equal to a1 x1 plus a2 x2 plus some b. So this b is, in linear terminology, this is also called intercept. And in machine learning terminology, this b is called a bias. So this is a bias term. Okay. So here also we are saying that the function, the hypothesis function that captures the relationship between the input and output, that is a linear function. So we will say it will be theta 0. Theta 0 will be our bias. Okay. So instead of b, I am writing theta 0. Or some, they also write w0. Some books write w0, we are writing theta 0. It is only the representation. Plus, so how many features are there? Two features. So theta 1 x1 plus theta 2 x2. So this is our hypothesis class. Okay. So let me write it again. So the hypothesis class in our linear regression is hypothesis class is h of x is equal to theta 0 plus theta 1 x1 plus theta 2 x2 plus dash 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 plus theta n x. So in this particular example, I have shown only theta 1 x1 plus theta 2 x2 because I assumed only two features of the input. But there can be total n features. So that is why I am writing like this. So this is a linear family. Or we can say this particular equation represents thousands of linear equations because every equation can change based on the change in these parameters. Okay, so this particular equation hypothesis is also written as h theta x. H theta x means that the parameters of this equation are theta. Okay, so h theta x is equal to theta 0 plus theta 1 x1 plus theta 2 x2 plus dash 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 plus theta n x1. So that means we have assumed that this is a hypothesis function that captures the relationship between the input and the output. Okay, and but I said that this hypothesis function, it changes with the change in value of these parameters, but our aim is to find one particular hypothesis function because it represents n number of functions, but we want to find one particular hypothesis function that best fits our data. And how can we find that? We can find that by finding the value of these parameters. So we want to find the value of these parameters. That particular value by which this particular quantity minus xi minus yi whole square, this is minimum because this represents the loss. So this I am writing for one example. Now if I have to written for n examples, so in our data set there are total n examples. So on every example I will find this particular loss. So I will find this loss. So this loss can be written as is equal to sum of all these losses. So summation of I running from 1 to n, because there are total n examples, h of theta xi minus yi whole square, and I will average it. Average is 1 divided by n. Okay, so that particular, those particular parameters theta 0, theta 1 dash 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 theta n will be optimal for which this particular loss, this is also called j theta, loss function, this particular loss is minimum. Okay, so our aim is that we have this j theta is equal to 1 divided by n summation I running from 1 to n h of theta xi minus yi whole square. Okay, so what we are going to do, we will change theta. How we will change theta, we will see that later, but we will change these theta. So this theta is theta 0, theta 1, or you can write it like this: theta is equal to theta 0, theta 1, theta 2, theta n. So this is n cross 1 column vector. Okay, theta. So how many parameters are in this theta? There are total n plus 1. So sorry, this is n plus 1 into 1. So where n is number of features in the input. So here we are having n features, so it was n plus 1. But the example here that we were showing, there were only two features, age and qualification. In this particular data set, our theta will have only three features. So that will be theta is equal to theta 0, theta 1, theta 2. So this will be our theta, and our aim is to find the optimal theta, and that particular optimal theta by which this particular loss is minimum. Okay, so what I am going to say, I will repeat it again, that in linear regression, so in linear regression, what we are doing is that we assume that there is a linear function h of theta x that captures this relationship theta 0 plus theta 1 x1 plus theta 2 x2 plus dash 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 theta n xn, such that we want to find h of theta x such that the output of this particular function is similar to the actual output. This is actual output, and this is the output given by a hypothesis function. Sometimes we also write it as y hat. So we want the output given by the hypothesis function is equal to the actual output. So then only we say that this particular hypothesis function captures this particular relationship. And this relationship, we have assumed that it is a linear relationship. But it is not always correct to assume a linear relationship. There may be a non-linear relationship between input and output also. In that case, our linear won't work. Okay, so you have to make assumptions very carefully. Okay, assumption should be done very carefully. Since we are discussing linear regression, so we will assume that the data has a linear relationship. Okay, and how we are going to now find these optimal parameters? These optimal, we have to minimize this cost j of theta. And what is j of theta? So our j of theta, so we have to find theta by which this particular quantity is minimum, and this j of theta is equal to 1 by n summation I running from 1 to n h of theta xi minus yi whole square. Okay, now let me write the same linear regression in matrix format. Okay, so let me write this in matrix format. So we know we have a data set. Okay, and that data set was like this: x1 y1 comma x2 y2 xn yn, sorry, xm ym, because we are assuming m examples and n features. This is our data set, and we are trying to find a hypothesis function. So we will first find h of theta x1, and that will be equal to h of theta x1 will be equal to theta 0 plus theta 1 x11 plus theta 2 x12 plus dash 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 theta n x1n. So this is for x1. What is for x2? It is theta 0 plus theta 1 x21 plus dash 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 theta n x2n. And how many data points are there? M. So theta h of theta xm will be is equal to theta 0 plus theta 1 xm1 plus dash 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 plus theta n xm. So these are our total m equations. And we know that these equations, these m equations, can be written in the matrix format. And how we can write it? So let me show it. So you can see that this is our h of theta, so it can be written like this. So h, so this is the matrix, so I will write it h of theta x1, h of theta x2, h of theta x. So I have combined these m outputs into one matrix, and that matrix is m cross 1. So it is m cross. Now from this particular side we can write this as like this. So I will write these equations in matrix format like this. So our theta, so let's assume theta is a parameter vector, theta 0, theta 1, theta, how many thetas are there? N. So it is a matrix of n plus 1 cross 1. Okay, and our x, let's take x as, so our every example we were representing like this. So x1 was, so it was x11, x12, x1n. Okay, so you can see here in the example x11, x12, x1n, but you can see that there is one additional term, theta 0. So to incorporate theta 0 with an x, with every input, we will have another feature that will be x10, and this x10 is always equal to 1. Okay, so for every example we will write, for uniformity we are writing x20, so this is also 1, and xm0, this is also 1. So we will say that there is additional feature, that is x10, and this feature is always equal to 1. Now this capital X, this input matrix, can be written like this. So we will write it, so it will be x1 transpose, x2 transpose dash 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 x m transpose. So basically what was x1? X1 was a row vector like this, and now I am writing here it is transpose. So it is transpose will be, this row will become column. So what will be the first entry? 1. What will be the second entry? x11, x12 dash 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 x1. Okay, or some people can also do, let's remove it, let me rewrite it again. We can have x is equal to, we can put these x's here in this particular matrix. So the first row will contain input of first example. Okay, second row will be the second example, third row will be the third example. Okay, so if we can write, so let me write it again here. So this x will be equal to, the first row is the first example. What are the features of first example? 1, x11, x12, x1n, 1, x21, x22, x2 n. So likewise this. So the last one will be 1 x m1 x m2 x mn. Okay, so what will be this particular matrix? What will be the size of this particular matrix? It will be, so there are m rows and n plus 1 columns. So why n plus 1? So n were these and we have added this extra one. And why we have added this extra one? To make this equation uniform. With theta 0 we are adding this particular one. Now these equations, the equations that we are capturing all the entire data set, it can be written in matrix format like this. So h of theta x will be equal to x dot theta. So what is x? X is this 1 x11 x21 xn1 dash dash 1 x1m xmn into theta. And what is our theta? Theta is theta 0, theta 1, theta m. And if we do the multiplication, matrix multiplication, so the first row multiplied with the first column, so it will be theta 0 into 1, theta 0 plus theta 1 x11 plus theta 2 x12 plus dash 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 theta n x1 n. Likewise the second will be theta 0 plus theta 2 x21 plus theta 1 theta 2 x22 plus dash 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 theta n x2 n. And the last will be theta 0 plus theta 1 xm1 plus dash 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 theta n x m. So you can also check the dimensions. This was m cross n plus 1 and this was n plus 1 cross 1, and its dimension, the final dimension here will be m cross 1. So there are m values, and how many m values, m rows, 1 2 up to m, and only one column, this one column. And it is equal to h of theta x. What was h of theta x? You can see h of theta x was this. Okay, so it is h of theta x. So h of theta x is h of theta x1, h of theta x2 dash 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 h of theta xn. So you can see from these were our equations, and output is coming in matrix format like this. So this is same as this. Okay, so that means we can write our hypothesis function h of theta x. So this is matrix here. Okay, hypothesis matrix, this is same as this h of theta x, because we are writing capital X here. Capital X here means matrix, entire data set. Okay, and this is equal to, in matrix format, x dot theta. This is also matrix and this is also matrix, this is also matrix. And how many points are in this matrix? M points. So it is an m cross 1 vector. So this one is m cross n plus 1, and this theta is m cross 1. And our aim is to find, so aim is to find optimal theta. And how we are going to find an optimal theta? We are going to find an optimal theta. We will calculate the error on theta. So that will be equal to this error on theta. on some particular theta will be equal to 1 by n summation of I running from 1 to n, okay, edge of theta xi minus yi whole square. Or I can also say it is equal to 1 by n, this summation, this we can write it like this. So this is h of theta xi from 1, give the values h of theta x1 minus y1 whole square plus h of theta x2 minus y2 whole square plus how many examples are there? Sorry, not n, it is m, because we have total m examples. H of theta xm minus ym whole square. So this is our loss. Okay, it can be written as 1 by m, then I will write h of theta x minus y whole transpose int h of theta x minus y. So I will show it why I am writing like this. So I am saying that this particular thing or this particular summation and this thing in expanded format can be written in matrix format like this. Okay, why like this? Let me show you here. Okay, so what is our h theta x in matrix? So it is h theta x1, h theta x2, h theta xm. Okay, and what is our y? So y is y1, y2 up to ym. Okay, and what will be h of theta x minus y in matrix format? It will be h of theta x1 minus y1, h of theta x2 minus y2, okay, dash 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 h of theta xm minus ym. Okay, this is our h of theta. And what will be its transpose? Its transpose will be the transpose of this matrix. Okay, so the transpose, so I will write h of theta x minus y whole transpose into h of theta x minus y. Let's see what will be this particular equation. It will be h of theta x minus y transpose. So this is this particular matrix. So let me write it as transpose. So it is transpose will be h of theta x1 minus y1. So this will be the first element. The second element will be h of theta x2 minus y2. This will be the second element, and mth element will be h of theta xm minus ym. So this is this particular transpose. And what will be h of theta x minus y? This is this one. So this is a single row and this is a single column. Multiplying single row with a single column in matrix format will give one element. So what will be that particular one element? So the first will get multiplied with the first element. So what is the first element? H theta x1 minus y1. What is the second element? H theta x2 minus y2. So let me add the first with first. It will be h theta x1 minus y1 into h theta x1 minus y1. So this is square plus h theta x2 minus y2 square plus dash 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 plus h theta xm minus ym square. Okay, so that means this particular entity, it is written like this: 1 by m, then these particular terms. So these particular terms, what are these particular terms? H of theta x1 minus y1 square plus h of theta x2 minus y2 whole square plus dash 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 plus h of theta xm minus ym whole square. Okay, this is equal to 1 by m summation I running from 1 to n h of theta xi minus yi whole square. Okay, so we find out both matrix and non-matrix equations. So in linear regression, let me summarize it. Linear regression, our hypothesis function for one data point is equal to theta 0 plus theta 1 x1 plus dash 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 plus theta n xn. This is for one equation. But for entire data set, training data set in matrix format, this h of theta x can be written as x dot theta. And what is x? X is an input matrix where each row represents one example. And at the beginning of each row, we have one extra one. Okay, so this is the x. And the size of this is m cross n plus 1. And our theta, this particular theta, it is a feature, it is an parameters that we try to find. And the size is n plus 1 cross 1. And this h of theta x, this is also a matrix of size m cross 1. Okay, so we want to find a hypothesis function, or we can say we have to find these parameters such that this particular loss j of theta is equal to, so our aim is to make h of theta x as similar as possible to y. Y is our actual output. So that is done by minimizing j of theta is equal to 1 by m summation I running from 1 to m h of theta x I minus yi square. Or in matrix format, we will write it, it is equal to 1 by m, not summation, 1 by m h of theta x minus y whole square. And we know that if we have a matrix A square, it is not A into A. In matrix format, this is equal to A transpose into A. So you should know this. This is the general matrix that we use. So it is equal to 1 by m h of theta x minus y transpose into h of theta x minus y. Or this can also be written like this, 1 by m. So we know h theta x. So h theta x is equal to x dot theta. So it is x dot theta minus y whole square. Or I can write it like this, 1 by m x dot theta minus y transpose into x dot theta minus y. So what was our x theta? It was hypothesis. So if our hypothesis is close to y, so this subtraction will be minimum. This subtraction will be minimum. That means our loss will be minimum. Okay. So this is all about linear regression. So in linear regression, we try to fit a linear equation to the data. So, but for fitting, we have to find these optimal parameters. And how we can find these optimal parameters? We will use those parameters that will minimize theta. Now, initially, we will make a guess for these parameters, these theta. We will make some guess. And on that guess, we will calculate j theta. Then we will change these thetas. Change the theta. We will change them repeatedly and check j of theta. And finally, when we reach to the minimum of j theta, we will consider those theta parameters as optima. But we should know how to change these parameters. Now here I am saying we have to change the theta, but we should know how to change the parameters, whether we have to increase the value of theta or decrease the value of theta. So that will be the aim of our next lecture. So what is the aim? Aim is how we can optimize this particular equation. Optimize means how we can find the optimal values of theta such that this particular quantity is minimum. That will be the focus of our next lecture. So let me stop this particular lecture here. We will meet again in the next lecture. Till then, goodbye.